Hello, this is Dr. Brown. We're going to continue in this video in our probability unit, and we're going to be talking about the normal distribution. Before we get into the normal distribution, I want to say just a word about probability distributions in general. They're not all normally distributed. You will see some that are rectangularly or uniformly distributed. And I'll tell you what that means in a second. Then there's a triangle distribution, and here is a normal distribution, the bell-shaped curve, which you probably have heard about. One of the things you should know is that the area under the curve for all distributions is equal to 1. That means 100% of the data is under the curve. The probability of a number being between A1 and A2 is equal to the area under the curve. Let's take a look at the next slide where we have, say, A1 and A2, and say A3 and A4. In this case, the width of the rectangles are the same, which means that the probability of the data being and between A1 and A2 is equal to the same as A3 to A4 because the areas are equal. However, if you looked at, say, a triangular distribution, the probability that the data is in this first shaded area is say call that probability 1 is going to be more than the probability that the data is in this shaded area. And of course, it's the same for a normal distribution. It turns out that the data is peaked at the mean, and the probability of data being near there is going to be greater than being further out. Now we're going to talk about the normal distribution in general. The normal distribution is a symmetric bell-shaped distribution with a single peak. This peak in the distribution corresponds to the mean, the median, and the mode, which are all the same. And notice that 50% of the data is to the left of the mean, 50% is above the mean. I want to also point out that the normal distribution theoretically goes from minus infinity to plus infinity, although since the area under the curve out here is going to be very, very small, the probability of anything being there is very small. Here are some normal distribution facts. As we just said, because it's symmetric, 50% are below the mean, 50% the data values are above the mean. Data values further from the mean become increasingly rare. The graph of the distribution is bell-shaped with tapering tails that approach but never actually touch the horizontal axes. Almost all of the area under a normal distribution curve is within three standard deviations of the mean. That's plus or minus 3 sigma. The total area under the curve is 1, which means 100% of the data is there. Next, we have an empirical rule, which we're going to make use of. It's called the 68, 95, and 99.7 rule. And it says, first of all, that 68% of the data is within plus or minus 1 standard deviation of the mean. 95% is within plus or minus 2 sigma of the mean. And finally, 99.7% of the data is between plus or minus 3 sigma. And as you look at this, you'll see that 34% is between the mean and 1 sigma and plus 1 sigma. 34% is between the mean and minus 1 sigma. And you can see the other percentages in each area. And of course, you get further and further away from the mean. The percent of the data that's there gets to be smaller and smaller. Let's do an example here. The test scores on a math exam are approximately normally distributed with mean 72 and standard deviation of 8. Draw the associated normal distribution curve and label the axes appropriately. Well, the mean is 72. One standard deviation is 8 above it, and that would be 80. That would be 2 standard deviations would be 88, and 3 standard deviations would be 96. And you continue to subtract off 8 as you go down, and you get 64, 56, and 48. And on the next page, I think I've done it a lot more neatly. 48, 56, 64, 72, 80, 88, and 96. And I've also put in the percentage of the data that's in each range there. Now, another example, you had scores on a standardized test were normally distributed with a mean of 510, standard deviation of 94. Use the empirical rule to complete the following statements and draw and label and sketch the distribution. Well, the mean is 510 and the standard deviation is 95. So we add 510 and 95 and get 605 for the top range for the 68% rule. And then we subtract 95 from 510. And we get 405. $415, I'm sorry. Get 415. And continuing to add 95 and subtract 95, we get 700. And continuing to do this, we get our ranges for the 68% rule, the 95% rule, and the 99.7% rule. So for 68% of the students make between 415 and 605, 95% are between 320 and 700, and 99.7% are between 225 and 795. And here is the curve with all the scores we just talked about, and the percent of the data that's within each range. Now, another example, you're making a gear for a manufactured bicycle part. They're normally distributed. They should have a spec of 34 inches. And you expect that the bicycle parts that are made are going to meet that spec within a certain tolerance. The ones that are being manufactured now have a standard deviation of 0.04 inches. And we want to fill out the 68%, the 95%, and the 99.7%. So basically the sigma is 0.04. So this is going to be 34.04. Subtract off one sigma and we get 33.96. And then add 0.04 and 0.04 for 2 sigma and 3 sigma. Subtract minus 0.04 and another minus 0.04 for the lower end, and then we get 68% is between 33.96 and 34.04, 95% between 33.92 and 34.08, and 99.7% between 33.88 and 34.12. And so we have this normal distribution here with the ranges of the various sigmas and the percentage of the data that's within each box. Now, we're going to talk about standard scores or z-scores. The empirical rule that we just talked about only applies when the value is exactly 1, 2, or 3 standard deviations away from the mean. Of course, this is not usually the case, and therefore we use what we call a standard score to find the number of standard deviations the data value is from the mean. It could be plus so many standard deviations or negative number of standard deviations. Now we can plot these z-scores on the standard normal curve called the standard normal distribution and look at where the data really lies and what where it is on the normal curve. So here's how you calculate the standard z-score. First of all, the z-score is going to be the value of the data minus the mean divided by the standard deviation. It's as simple as that. If it's positive, then the data value is above the mean. If it's negative, then the data value is below the mean. So here's an example. Scores on a standardized test were normally distributed with a mean of 510 and a standard deviation of 95. And a score, one student makes 365 on the test. They want to know what his standard score is. So on the next page, we write down z is equal to x minus the mean divided by sigma. His score was 365 and the mean was 510. We subtract that off and divide by the standard deviation and we get minus 1.525. So this student who made 365 is about right here, and he's minus 1.525 standard deviations below the mean. Another example. Scores on a standardized test were normally distributed with a mean of 510, standard deviation of 95. Suppose a student's z-score is 2.2. This means he's 2.2 standard deviations above the mean. So let's figure out what his score was. Well, if z-score is 2.2, that's equal to his actual score minus the mean, which is 510, divided by the standard deviation, which is 95. So we have to solve this equation for x. And so let's just write it over here. 2.2 equals x minus 510 divided by 95. To solve for x, we cross multiply and we get x minus 510 equals 2.2 times 95. And so x is going to be 2.2 times 95 plus 510, which is equal to 719. So this student is about right here. And you can see he's way up there in the top tier of the population. And the last thing I'm going to show you is a curve that can be used to ascertain what percentage of the data is below your score and or above your score. And you can see the z-scores here. If you have a z-score of 0, it means you made the mean. If you had a z-score of 1, it means you're 1 standard deviation above. And that means that 84% of the data is below you, and basically 16% is above you. If you were a 3 sigma score, you're ahead of 99%, 99.9% of the data, and 0.1% of the data is above you. Anyway, that is the video on the normal distribution.